In this presentation, we are going to talk about AI transforming engineering document review. So to start off here, I'm going to talk about my pet peeves and sort of ground rules about when I watch these AI types of presentations, and then maybe you can judge me against my own ground rules. So my pet peeve number one is that we use this term AI rather generically to talk about a whole suite of different technologies. We put them under this umbrella of AI. A lot of it's not really intelligent in the classic Turing test sort of a way. And also, there are very different tools. So languages and images require very different technologies. When you get a commercial LM software, Gemini or ChatGPT or Copilot or Claude, they include that image generation module, but that's a very different algorithm from the language module, right? And so I think we need to differentiate between image generation and language processing. Also, none of the packages that are broadly available right now can read architectural drawings, which is really important. And there's a lot of image reading stuff out there, from facial recognition to QR codes or whatever. But at this point in time, there is not a broadly available commercial package reading architectural drawings or engineering drawings. So my pet peeve number one, in my opinion, at this point, engineers and technical professionals need to be talking about what specifically we're doing, what tools are we using to do those things, and what tasks are we actually using them for. Most of this presentation, I'm going to talk about large language models, LLM, or language models, LM. So I'll try to refer to them as LM or LLM whenever I can, but I'm sure I'll slip up and call them AIs. My second pet peeve is that too much of the conversation is in future tense and often future conditional tense. We went to the ASHRAE conference in Orlando this year, and I think there were 4 different presentations that had AI in the title. They were well intended because it was super popular, but all of them were about this is what we think we could use AI for, or this is what AI can probably do. To me, in my opinion, that's not super useful right now. These language tools have been in our hands for about 2 years. So it's not so important what you think the future of the tool is. It's really important to be communicating with each other what we have been able to do with them, what we are able to do with them right now and in the past tense, what we've tried and failed to do with them. And so I'm going to try to talk about that during this presentation. I will show failures here. So some of what we'll be talking about is stuff that we've tried to do and not had really good results. Okay, so another little bit of introduction here. This is my favorite book that I've come across on the topic in the last year and a half or so. This author here, Ethan Mollick, is a business school professor. So he is essentially encouraging his MBA students and business school students to use commercially available language models like ChatGPT or Copilot or a Claude. And he's able to compare, like, what can the students do when they use these tools versus what can they do when they're not using these tools. So it's really a good narrative. He has these 4 rules that I kind of want to use as a framework for this presentation. Rule number 1, bring the AI to the table. Always bring the AI to the table, no matter what you're doing in your day-to-day life. Just bring the tool to the table, like first thing in the morning. Rule number 2, be the human in the process. These are tools, so there's always going to be a human in the process. There's a human that has to feed something into the tool, and then there's a human that's looking at what's coming out after the tool. So as engineers, we know this concept. We're in responsible charge of the work. Rule number 3, assume the AI is a human and define its role. We're going to talk about this concept a little bit later. For language models, this is really important. It's called characterization. Language models are not people. They're stochastic parrots, so there's no sentience there. That's just statistically looking for the next word to put on the screen to make you happy. But it's doing that so fast and with so much processing power that it shows up like a character. And the default character of a language model is this enthusiastic 22-year-old intern that comes into the office and always wants to impress you, drinks tons of coffee, and always Googles stuff. They say words like vibe check, and then they really like to hear the sound of their own voice, right? They go, oh, did you know this? And did you know that? Pay attention to me. Keep talking to me. That's the default character of Gemini and ChatGPT and Copilot and Claude. What do you want to talk about today? Oh, you want to talk about that? Yeah, I can talk about that. Did you know this? Did you know that? They're super enthusiastic. They want to talk to you. They want to give you information. Sometimes they don't even care if the information is right, which is the problem of hallucinations that we get within these language models. So one of the best ways to use the tools is to tell that language model what character you want it to act like, and then it will enthusiastically act like that character. Rule number 4 is iterative improvement. And so it is really important to understand how and where the tools are working and in what situations the tools fail to produce the tools that they want. For me, this has been hard. When I try something with the language model and it gives me gibberish or garbage, then what I want to do is walk away and do it the way that I've always done it. But that is the learning moment, right? Okay, it didn't work. What didn't work? Is there anything that I can do differently with prompting? Is there anything that I can do different in terms of what I'm sending over and what I'm expecting back? So that's important. Anyway, so let's move into examples. First thing I'm going to talk about is my existing process. So for engineers that are doing Kaiser design work, they've probably seen this checklist, right? This is our process. The way our process works is that if you're a consultant or a commissioning agent and you write a basis of design or a commissioning plan or a commissioning report, then you file it. Ultimately, it comes to me. I send it to one of my engineers to review. And since about 2017, we have standard checklists for basis of design and commissioning plans and commissioning reports. This is the standard checklist for an electrical basis of design project. And so this would go to one of my engineers under we'll call it the old process. So rule number 1, invite the AI to the table. So the first thing we did was we took these checklists, all of them, and developed them into a series of text prompts that we can use within the language model. That was step 1. Rule number 2 is to be the human in the process. And so this is the process map for what we're actually doing with the language model. And the language model's job is the little green circle down in the bottom corner there. So basically now a document comes in, it goes to my engineer loads it into the language model, puts the prompt into the language model next to it. The language model responds to that prompt. Then there can be iteration. Sometimes the conversation needs to continue, or you can ask the language model to clarify its answers or redo its answers to certain prompts. You can ask it to reformat what it's put out. So there's a little bit of iteration that goes there. And then that text winds up in the hands of my engineer, who issues out to the consulting team. So rule number 3, treat the AI like a person and tell it what kind of person you want it to be. Okay, so here's where I'm going to give the illustration to this. So example number 1, I take a basis of design document and an HVAC checklist, and I drop it into the language model. And the prompt is very simple. Review the CAP 029115 basis of design file using the checklist. Great. So here I get a set of answers. This is what it looks like when I do that. And I'll have you in particular look at that little circled section for load calculations. Yes, the document includes a summary of the cooling and heating load calculations on page 3. It provides details on thermostat settings, cooling supply, and construction data. Okay, thank you. So let's look at example number 2. Same file that I'm going to give to the language model, only this time I'm going to use what we call characterization. So the prompt is, you are a research analyst who uses only the provided document to answer questions. You must quote the exact language from the document to support your answer. If an answer cannot be found verbatim, you reply, not found in the document. Do not paraphrase, summarize, or infer. Review the attached document using the attached checklist. So the thing that I'm telling it to do is the same, but I've provided this characterization. And this is the results that I get from that. Very different set of results. First off, I very frequently see this thing not found in the document, not found in the document, not found in the document. And then the answer that I'm actually getting from for the same question that we looked at under load calculations is now a direct quote. It tells me, yes, I found this on page 3. Here's the direct quote of what I actually found on page 3. So this is a much, much more useful way of reviewing engineering documents, right? It does cut down on the problem of hallucinating answers, or we were having problems with the LMs hallucinating questions, hallucinating answers, finding things on page numbers that weren't actually on those page numbers. Using this characterization cuts down on that significantly. So here's some of the characterizations that we've used and had some good success with. The top one, I think, is the one that we use the most frequently. You're a research analyst who only uses the provided documents, etc. And it says right in there, always include page numbers in your citations. If it's not found verbatim, say not found in the document. No paraphrasing, summarizing, or inferences. And the rest of these roles have similar sorts of directions. We're telling the language model what type of person we want it to do. That last one down at the bottom is kind of cute, right? You are an expert witness under oath. You can only answer using the exact language found in the source document. You must cite directly and cannot speculate or offer opinions, right? If the question is outside the document, say, I cannot answer based on the provided material. And where did we get these characterizations? Well, that's actually easy too. You ask the language model, you tell the language model what kind of task you're trying to do, and then ask it what types of characterizations might be useful for doing this particular task, and it'll spit some of these characterizations out. So there's a whole bunch. This is called prompt engineering, and there's a whole bunch of training that's available right now on prompt engineering. You can go to an 8-hour Google class on prompt engineering, and their framework for prompt engineering is called task, context, reference, evaluate, and iterate. To me, the most important parts of that are the first 3, task, context, and reference. And you can remember that with the mnemonic time compression ratio. I have a little time compression ratio mascot there who looks like they're doing time travel rather than time compression. But the example is sort of color-coded here on this slide, right? I ask it to do a task, review the basis of design using the checklist. Then I give it some context. That includes the characterization that I want it to take on while it's doing that task. And then I give it references. Only use this document to find answers on the checklist. Don't look at any other files. Don't look on the web, right? So that's the great way for using these language models. So here's some of the languages, or here's some of the lessons learned that we've gotten out of this process. And the first is that you don't necessarily need to type all of your prompts into the chat box or paste all of your prompts into the chat box. You can we're keeping the checklists themselves in files, and then you could drop 2 files into the chat and it handles that just as well. In fact, sometimes for longer sets of checklists, it's better to hand it files than to try to paste everything into the chat. The chat usually has some limitations about how many characters you can actually enter into the chat window. That being said, these language models are awful at file management. We internally use Microsoft product, the Microsoft Copilot. And when you tell Microsoft Copilot to go find a file in a certain directory, it's awful at doing that. When you give it a general search parameter and tell it to go look around for these things, then it finds things. But when you try to tell it, go look here for this file, then it's absolutely awful at doing so. And then the final lesson learned is that using the language models to do these engineering design reviews has revealed a lot of human variance. I have 4 different engineers that could review an HVAC basis of design. And just looking at the historical work that they've done in the last couple of years against what the language model would do, it's very clear that, one of my engineers would let you get away with a certain thing on a project that another one of my engineers would never let pass, and sort of vice versa. This isn't a very astute observation. We already know this from plan checkers and inspectors. You can give 5 different plan checkers or 5 different inspectors the same building code, and they will find wildly different things, right? And so if we start using some of these tools as a first step, I think what can happen is consistency, and some depth of reviewing. Okay, so let's talk about another example, and this is our energy targets that we have within our standards. So right now, within our standards, we do have energy analysis requirements. Every time that our consultants are doing work in existing buildings, they're supposed to look at these energy targets and assess the project relative to the energy targets. So this slide here is a quote from our standards. And we're not sure how well that is getting done. So we want to check that out this year and see if we can assess how effective these energy targets are within our standards. So rule number 1, bring the AI to the table. Well, the idea that we had was to come up with this scorecard. It's called an Energy Smart Design Scorecard. And so we came up with this scorecard, and how would it work? Well, what it would work is it would be like having a teacher's aide grade papers using a scorecard, right? So there's 3 sections to the scorecard. Section 1 is understanding the existing energy signature. Does the document include information about the energy signature of the building? If it does, give it 5 points. If that information is broken down into electrical and natural gas, give it 5 more points. If it's related to monthly weather profile, give it 5 more points. And if they offer any analysis, then give them more points. So overall, 45 points available in section 1. Section 2 is understanding the project impact. 25 points available in that section. And then section 3 is our actual energy targets. 30 points available in that section. So that's kind of the design of what we would do. Rule number 2 is to be the human in the process. Well, that's pretty easy. I'm the teacher. Hey, language model, you are the teacher's aide. You're grading these papers based on this scorecard, and then you're going to give it back to me. And rule number 3, tell the AI what kind of person you want it to be. I want you to be a teacher's aide. I want you to score this thing, find examples within the document, and then score it. Okay, fine. So how's that going? Well, right now, currently, all of the projects that I've tested, and I've only tested between 5 and 10 projects, but all of the projects that we've tested with the scorecard are getting a score of 0, which could mean 2 things. It could mean that all the projects that we have received last year are legitimately getting a score of 0 according to this Energy Smart scorecard, and we're not actually getting Energy Smart designs at all. That's one possible outcome. Or it could mean that this process just isn't working for one reason or another. Maybe the questions are too specific. Maybe we're not able to find things in the text. Maybe the engineers are doing the work and it's just not readable by the language model. So we'll have to see where that goes. But even within this, we've had some lessons learned on this process. The first one being that we tried to write that, 2 slides ago, I showed you a version of the scorecard that was in Excel, and that just did not work out at all. Having, a question in one column and the points available in another column, that just didn't work at all, right? And so we had to put it into text and make it a simple text request, and then it was able to do the scoring. The second thing is that with this process, we saw some wild hallucinations. Not only did we see hallucinations of answers that were supposedly found in the document that didn't exist in the document, we also saw the language models hallucinating questions, hallucinating entire sections that they wanted to add to the scorecard. And so some strong prompting on this is definitely going to be necessary to carry out this type of process. And then the third lesson learned is that what I really want to do is contingent scoring, right? If the project only has to do with natural gas and doesn't actually have anything to do with electricity, then I'd like to be able to say, okay, the electrical, maybe section one doesn't have 45 points available, it only has 30 points available. And then, you get a certain number of those available points and an overall percentage. But it's been completely unable to do any kind of contingent scoring like that. I think that's going to require more of a two-step process or a multi-step process, right? Okay, but let's move off of the topic of reading. The topic of reviewing is the topic of reading, and let's move into the topic of writing, which will come together, by the way, towards the end here. So as I said, my job involves writing our Kaiser standards. So we have our engineering standards, commissioning, plumbing, HVAC, electrical, etc. And by the way, right now you can go to whatever your favorite chatbot is, Gemini or ChatGPT or Copilot or Claude, and you can ask, what are the Kaiser standards for this type of project, or what are the Kaiser standards for this type of equipment? And very often you'll get an answer. Right? This one happened to be Claude. And I think Claude was the most conscientious. It actually said, Kaiser standards are proprietary and I don't have direct access to them, so please contact Kaiser. So thank you very much for that, Claude. But I went ahead and asked Claude this question: what are the GSA design and construction standards for a rooftop package HVAC unit on an office building? And it gave me standards. Now, I don't know if these are right, but I do know that it went in there and found some standards to spit out to me and give me the conversation. I think the point here for me is that ultimately, as somebody who writes standards, I want to take control of the content that these language models are going to be finding, and I ultimately want it to produce answers that are correct. So that's what we're starting to do. So rule number one, invite the AI to the table, and rule number two, be the human in the process. So here's what we've done. We've taken all of our standards and moved them into a straight text format. Most LMs are very good at reading text, or I should say LMs are very good at reading text. They can also read tables. They're not very good, or they can't read data from images. So we stripped our standards down to a very basic text format. It's a single document with a bunch of different chapters. And then we're using the language models to read that document and try to find answers to questions within the document. As I mentioned, internally, we use Microsoft Copilot. That's kind of great because then I can actually ask the questions from within the Microsoft Word interface, right? But with any other model, I can just drop the document into the language model and ask it questions, right? So here's the example, right? Give me an applicable standards, give me a checklist of applicable standards for my project. You're a compliance officer and I am a project manager. I'm working on a boiler replacement project, which is an emergency project. The existing boiler has failed. Use only this document as a reference to answer the question. And it does. It gives me a checklist of applicable standards. These are not correct, by the way. There's actually, there's some things in here that I found that I didn't like, and that I think it's more important to say there are some things here that it didn't find that I would have liked it to have put into its answer, right? To a follow-up question, does my controls design team need to, and commissioning team need to implement ASHRAE Guideline 36 on this project? And the answer that I got back is yes. It said, yes, absolutely, your team needs to do that. And unfortunately, that is not really the answer that I'd like it to give. I'm not sure that I want the team to have to follow Guideline 36 on an emergency boiler replacement project. But I can ask another follow-up question. So another follow-up question is, okay, explain that last answer logically. Where in the document did you find the requirement for ASHRAE Guideline 36, and how did you determine it was applicable to the project? And so it answers that. It basically tells me what sections it read in order to find the answer that it found. So that's really useful. Now I can go back and I can start to tweak those sections of the document so that it finds the answers that I actually want it to find. Okay, so some lessons learned and some implications, I think, of this process. So the first thing is that is kind of the example that I've shown you. The language models seem to be very good at answering sort of short questions where you go ask it to find a specific thing within the document. I'll tell a little story here as an example. A solar company came to my house and they were offering to upgrade my solar package. And they sent me this contract. You know, they're in my kitchen. They email me this contract to sign. Okay, here's your contract to sign. And it, you know, it's a 150-page contract or whatever that I didn't want to read. But I uploaded it right into a language model, and then I asked specific questions. You know, what are my financial obligations under this contract? How much do I need to pay now? How much do I need to pay later? In what events would I have to pay something now? And so I had a 5-minute conversation with the language model about the contract. It's very good at going through a large document and finding specific answers to specific questions. Now, if I would have asked it to, you know, like you saw earlier, if I ask it to write a checklist, combine this document into a checklist that's applicable to my project, it is not very good at that. And so I don't know whether we need different prompting, or maybe that's just not something that it's very good at all. But that's a lesson learned. I think the big implication here is that if your job involves reading, which many of our jobs involve reading, then it's pretty you should be using language models to do reading for you. And we know this is happening. We've heard rumors about design firms and contractors and estimators using language models for specification review, particularly like if you're an estimator and you just want to find, hey, do the specs include, you know, this item? Then you can go ask that. A language model is going to be very good at reading a 1,000-page spec and finding any and all references to, you know, whatever little detail that you're looking for, right? The second implication here, though, is that if your job involves writing, which my job does involve writing, then I think you have to assume that you're going to be read by a language model. From this day forward, whatever you write is going to be dropped into one of these language models to be read. And so you can throw it in there and test it before you send it. And so this is one thing that we're doing. And it kind of brings us to our last topic. What about writing engineering documents, knowing that it will be read by an automated reader? We are right now posting our language model checklists to a publicly accessible Google Drive folder. Anybody can use that link. It's tiny URL, kp-llm-prompts. And so if a design firm that's working for us is putting together a basis of design today, you know, and you're going to submit it at the end of this week, then you can take that basis of design, go to your favorite language model, and using these checklists, you can actually check it yourself, and you'll get to see our review comments before we write them, right? So it's like time travel. Because the minute we get the document, our process now is that we're going to take that checklist and the document and drop it in there and check it. So you can write your document, check it first, and if it doesn't find all the answers in there that you want it to find in there, or that you want us to see in there, then you can adjust your document so that the language model finds it. And this is really important for us as engineers. In particular, engineers are not fantastic writers, and so I think this is something that we can use as a test to make sure that the stuff that we're writing actually meets the intent of what we're writing it for. This is an example. We actually have a standard where we have some questions about BTU per square foot. It's down at the bottom there. Does the project contain a cooling system that's greater than 25 BTU per square foot? Or does the project include a fan system that's sized at more than 0.7 CFM per square foot, right? And this is a real example. I took a basis of design and tested it with that question, and it says not found in the document, not found in the document, not found in the document, right? Well, it actually is in the document. And if I had a human engineer, I can check this very easily. But in this case, the square footage was buried in Appendix B, in the middle of the load calculations. I had to sort of scroll through and found it in 2 locations and added it up, between the systems to find out what the actual square footage was of the project. And then does it contain more than 0.7 CFM per square foot or more than 20 BTU per square foot? Well, I had to go find back in the appendices, what's the BTU of the system, which was in tons, and I had to convert it to BTU, and what's the CFM of the system that they selected. Okay, I found that. It's on the schedule sheet that they included in the appendix. And then I divide by the square footage, right? So, and in this case, it was over both of those numbers, but the language model wasn't able to check that. And so the lesson learned here is that if you know that a language model is going to check for 0.7 CFM per square foot and 20 BTU per square foot, then you can just write that into the text of your document and say, hey, my cooling system is 15 BTU per square foot and 0.6 CFM per square foot. And then the language model is going to find that answer right away. And that saves everybody time, right? Okay. So let's take the conversation a little bit further. I actually have a library of 20 basis of design documents written by 20 different design firms. And so I started this conversation here. Okay, create a common outline for basis of design documents. You are a technical writing expert and coach, so I want you to write a common outline for a basis of design, right? And it gave me a common outline for a basis of design, which actually, if you go through it, it's pretty good. It is a common outline for a basis of design. Follow-up question. Write a checklist for each of the 14 sections of the common outline, and what questions need to be answered in each section. And it gave me that. Now, obviously, this is the beginning. This conversation went on quite a bit. I've actually tried giving the language model a basis of design that we have and telling it to rewrite the document into the common outline. That didn't work out super well. Again, I don't think these language models are fantastic at sort of recombining documents into new ways. They're much better at answering specific questions. So I think we'd have to be careful with that, maybe turn that into a multi-step process. But if you think about it, if you think about our engineering documents, like a basis of design and a commissioning plan or a commissioning report, a sequence of operations, a set of specifications, it's pretty easy to imagine that our job could change, right? That our job as engineers would be to work out the content, solve each piece of the puzzle. And then if we can put all the answers to the relevant questions into some sort of data repository that's in language, then we could, kind of figuratively have a professional writer write the document using a strict set of technical writing standards. And then, of course, we're going to be the human in the process, right? We're feeding it the data, we're reading what it comes out with, or we're having another language model read what the first language model wrote, something like that. So I think that's the conversation we're going to be starting in the the next couple of months. So that's kind of where we are in the future. Not in the future, but in the present. I tried to stick to present tense in this conversation. I'm sure I went off into the future a little bit. We are using language models to read better, to write clearer, and to bring more consistency into how we review projects. It's still chunky, but it's already changing our work and the way that we're working. So that's what I've got for the presentation.